Hi there, amazing people, students, lovers of chemistry, and each and every one of you who subscribe to this space. I'm so excited to be here with you today on the penultimate episode on this series that we've had on learning how to name organic compounds thus far. And today we're wrapping up with part 6, where we deal with some practice questions that helps us to master the concept of naming organic compounds. So without any further ado, let's get into what we have for today. We're just going to be solving examples back to back. So sit back, relax, and enjoy every bit of today's lesson. So on the screen right now, we have this compound and we have been asked to name it. So first things first, we number the carbon atoms that are present in the structure. So to do that, we have CH3 bonded to CH2 bonded to CH3. We have 1, 2, 3 carbon atoms. 3 carbon atoms gives us the root name or the parent name PROP, prop. Next thing we need to identify is if there is any functional group. There is no functional group, okay? But we know that we can see that there are only single bonds present throughout the structure. So that tells us that it is an alkane. And alkanes usually have the suffix ane, which stands for ane. So altogether, we have the final name to be prop plus ane. That gives us propane as the name of this compound. So now that we have done that, let's move on and proceed to the next compound we want to name. We have the next compound on the screen right now. And as you can see, this is what the structure looks like. Let me be more illustrative with this one. We have CH3 bonded to CH. Remember, we can see this bracket which contains a CH3 and it is connected to this CH. All right, so that means this CH is bonded to CH3. That CH3 is what I just identified over here. So this CH is now bonded to CH2. So we have CH2 bonded to CH3. This is what the structure looks like. So first things first, we need to count the longest continuous carbon chain. So how do we do that? We can start counting from the left to the right. When we do that, we have 1, 2, 3, 4. If we count from the right to the left, it will also be the same number of carbon atoms. 1, 2, 3, 4. So we have 4 carbon atoms in the longest parent chain. That gives us the root name BUT, but. Next thing to analyze is, are there any branches of functional groups? Yes, there is a branch over here because anything that is not part of the parent chain becomes a branch automatically. And we counted from the left to the right. 1, 2, 3, and 4. And as you can see, there is a branch on carbon number 2. And we counted in such a way that we gave this branch over here the lowest number possible, because if we had counted from the right to the left, this would have been 1, 2, 3, 4. This would have been on carbon number 3, but now we counted from the left to the right, so we have on carbon number 2 a branch which is CH3, and CH3 has the name methyl. So to name that, we'll have the prefix 2-methyl. That number 2 there shows the position of the methyl branch, and then methyl shows that it is CH3 that the branch is. So the name of the compound or the name of the parent chain is 4 carbon atoms. So that gives us plus BUT, and then it is an alkane because only single bonds are present throughout the structure. So we have ane as the total suffix. So altogether we have 2-methyl butane as the name of the compound. I'm sure you're seeing every bit of how we're naming these compounds one after the other. Next on our list is this compound on the screen right now that we want to name. So we have this, let's redraw it in a way that will be more illustrative for us to see. We have CH3 bonded to CH2 bonded to a CH which has a double bond bonded to another CH, and then it is bonded to CH3. So now we have this compound. We want to name it. So let's go ahead and count the number of carbon atoms that are present in the compound. So we have 1, 2, 3, 4, 5 carbon atoms are present in the compound. 5 carbon atoms tells us that we use the name PENT. All right. Next thing to do is to identify if there is any functional group or multiple bonds present. There is a multiple bond over here. So we need to count the longest chain in such a way that this multiple bond is given the lowest number that is possible. So to do that, we can either count from the left to the right, or we can count from the right to the left. So let's see which one will be correct. If we count from the left to the right, you can see this is 1, 2, 3, 4, and 5. This double bond was placed on carbon number 3. If we count from the right to the left, however, this will be 1, 2, 3, 4, and 5. This double bond will be placed on carbon number 2. So that means our double bond is on carbon number 2. And we have 5 carbon atoms, which gives us the name PENT, pent. So in order to name these compounds, we have the parent name, which is pent, plus we have a double bond, and it is on carbon number 2. So we indicate the number and we indicate the suffix, which shows that it has a double bond, and double bond shows that it is an alkene. An alkene usually have the suffix ene to end their name. So adding everything together, we have pent 2 in as the name of the compound. I'm sure you're seeing every bit of what's going on here and you're enjoying every bit of this lesson. If you are, please like, share, and subscribe for more content to come your way. Next on our list, we have this organic compound on our screen right now, and we want to name it. So let's redraw the structure in a way that will be more illustrative so we can understand it better. We have CH3 bonded to CH, and that CH has a functional group OH attached to it. So let's indicate the OH, and that is attached to CH2, which is attached to CH3. All right, so now that we have everything in place, the first thing we want to do is to identify the parent name. And how do we do that? We count the number of carbon atoms that are in the longest chain. So we have 1 carbon atom, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms. 4 carbon atoms tells us that we use the parent name BUT. But now the next thing to identify is if there are any functional groups present. And we have a functional group present over here, OH. This is an alcohol functional group. An alcohol functional group usually ends with the suffix OL, all. So we have a functional group, and on which carbon atom is it placed on? It is placed on carbon number 2, because we counted in such a way that this functional group is given the lowest number possible. We counted from left to right. If we had counted from the right to the left, this would be 1, 2, 3, 4. This would have carried number 3, and number 3 is higher than number 2. So that's why we counted from the left to the right, so that this guy can have number 2. So that functional group is on carbon number 2. All right, so now let's go ahead and indicate everything in place. So we have 4 carbon atoms, which is BUT, plus it is an alkane because only single bonds are present throughout the structure. So we have AN, since it's an alkane, and then plus the functional group, which is an alcohol functional group, and the number is number 2. 2 all. So altogether we have butan 2 all as the name of this compound. This number 2 is showing us that there is a functional group, an alcohol functional group placed on carbon number 2. I'm sure you're seeing how each and every one of this is playing out. All right, so now that we have that done, let's progress into some more practice questions with progressive difficulty. We're going to be going from easy to hard, from simple to complex. So we have this simple structure over here. We have CH3 bonded to CH2, bonded to CH2, bonded to CH3. So this is easy, easy peasy, like what's queasy. We have one carbon atom, two carbon atoms, three carbon atoms, four carbon atoms. That tells us that we use the parent name BUT. And it's an alkane because only single bonds are present. Altogether, we have butane as the name of the first compound. This is butane. The next compound, however, has CH3 bonded to CH2, which is bonded to CH that has this methyl substituent or methyl branch, which is now bonded to CH3. So let's go ahead and name this compound. First things first, we need to identify the longest continuous chain. All right, so we have 1, 2, 3, 4 carbon atoms. So we use the parent name BUT as well. Now we have a substituent or a branch over here. So we need to count in such a way that this guy will be given the lowest number possible. Counting from left to right makes this guy to have number 3. But if we count from right to left, that will be 1, 2, 3, 4. This will have number 2. So we have to count from right to left. So counting from right to left, we have number 2 carrying CH3, and that is methyl. So to identify the name, we have 2-methyl plus the parent name, which is BUT, and it is an alkane because only single bonds are present. So when we add all of these together, we have 2-methyl butane as the complete name of the compound. Did you see how we carried that out? So now we've dealt with easy and basic structures. Let's move into more complex structures, the ones that have functional groups attached to them. So we have the first one being CH3 bonded to CH2, which is now having OH, or an alcohol functional group. So first things first, let's count the base name, the number of carbon atoms that we have. We have 1, 2. That's right to left. I started from this right hand side because that is the end that will give the lowest possible number to this functional group. All right, so since we have 2 carbon atoms, then we use the name ETH, F. Now, the next thing to identify is the functional group. The functional group is OH, and OH usually ends with OL, all, as the suffix. So adding everything together, we have ETH, the parent name, plus AN, which is an alkane because it has only single bonds present in its structure, plus the functional group's name as the suffix. So we have ethanol as the name of this compound over here, ethanol. And then number 2, we have CH3 bonded to CH2, bonded to CH, having an OH functional group, and then bonded to CH3. So let's count the number of carbon atoms that we have. We are giving priority to this guy because he's the one having the functional group. So to give the lowest number possible, we are counting from the right to the left. 3, 4 carbon atoms. We use the parent name BUT. But on carbon number 2 now, we have the functional group all, which is an alcohol. So adding everything together, we have the parent name BUT plus it is an alkane because only single bonds are present, and then we have the name of the functional group, which is all, and it is on carbon number 2. So we have 2 all. So identifying everything together, we have butan 2 all as the name of this compound. Now, some of you might be wondering, why didn't I identify the number on which the alcohol functional group was placed in the first one, since I'm doing the same thing for here? Well, the thing is, in the first one, CH3, CH2, and OH, this was already placed on carbon number 1, because this was the first carbon atom, this was the second one. So there was basically no need to say ethan 1 all, because this functional group was already on carbon number 1, so we just went directly. Okay, so let's go ahead and name the third molecule. The third one says CH3 is bonded to CH, which is doubly bonded to CH, and then that has CH3 attached. So let's go ahead and name this compound. First of all, we have 1, 2, 3, 4 carbon atoms. That is the parent name BUT. But next thing is to identify the functional group or multiple bonds. We have a multiple bond over here, and we want to count in such a way that will give this the lowest number possible. So counting from left to the right, this double bond is on carbon number 2. So we have a double bond on carbon number 2. If we count from right to left, this will be 1, 2, 3, 4. So this double bond will also be on carbon number 2. All right, so we have the identification of the double bond, which is 2 in. All right, the parent name is but rather. So we have BUT plus the identification of the multiple bond, which is an alkene on carbon number 2, or a double bond on carbon number 2. So altogether we have but 2 in as the name of the compound. I'm sure you're seeing how each and every one of these is playing out. So next thing, we're dealing with a more complex structure over here. Now we have multiple groups and rings. So let's go into what we have. All right, now so we have the first question, or the first compound to name. We have CH3 bonded to CH, which has an OH functional group attached to it, bonded to CH2, which is now bonded to COOH. So the first thing we want to do is to identify the parent name, which is done by counting the number of carbon atoms that we have. So we have 1, 2, 3, 4. All right, so we have BUT as the root or the parent name of this compound, since there are 4 carbon atoms. The next thing to do is to ask yourself, are there any functional groups inside this compound? Yes, there are. In fact, we have 2 functional groups, as a matter of fact. You can see one functional group over here, COOH, and you can see another functional group over here. So now that we have more than one functional group, it therefore means we need to give priority to the higher functional group. And in order of priority, COOH, which is carboxylic acid, is greater than OH, which is an alcohol. So we give priority to this guy. How do we give priority to it? We are going to count from the end that is closer to it, and it is going to determine the suffix of the name of this compound. So now that we have COOH, the suffix of this compound is going to be oic acid. So we have butanoic acid as the root name of this compound. So let's keep this name aside, because it's going to be useful when we determine the details of the other parts of this compound. So now that we have determined that, we have our counting pattern to start from the right hand side to the left hand side, because this guy is being given priority. So we have 1, 2, 3, 4 carbon atoms. 4 carbon atoms has already been identified by this BUT. But so the next thing we are to do is to identify this alcohol functional group. Now, when OH is acting as the main functional group, we use the suffix OL. But when it is not the main functional group, we use the prefix hydroxy. So now that we want to identify the position of this OH, It is on carbon number 2. I beg your pardon, it is on carbon number 3 because our counting is from the right hand side to the left hand side. So it's not on carbon number 2, it is on carbon number 3. So to identify the position of the alcohol functional group, it becomes 3 hydroxy plus the other name, butanoic acid. So altogether we have 3 hydroxy butanoic acid as the name of the first compound. So let's deal with the name of the second compound. The second compound, we have CH2 having an OH functional group bonded to CH2, which is bonded to CHO. All right, now, so let's go ahead and name this compound. First thing we want to do is to identify the longest continuous chain. So we have 1 carbon atom over here, 2 carbon atoms over here, and 3 carbon atoms. 3 carbon atoms gives us the name BPROP, prop. Okay, PROP, prop. Next thing to do is to identify the functional groups. We have 1 functional group over here, CHO. CHO is the aldehyde functional group. When we have the aldehyde functional group, we use the suffix al, Al, and we have the hydroxyl or alcohol functional group over here. So now that we have 2 functional groups, it means we need to assign priority to the higher one. And in terms of priority, aldehyde comes before alcohol. CHO has a higher priority than the alcohol. So that means this guy will be the suffix and this other guy will be the prefix. Okay, if you're lost to anything that I'm doing, I suggest you go back to the previous videos in this series where I broke down every concept step by step, or you can also let me know in the comment section and I'd be willing to make a video on that. So now for the prefix, let's identify it. This is carbon number 1, carbon number 2, and carbon number 3. So on carbon number 3 we have OH, and OH is identified as hydroxy. So to identify this, we have 3 hydroxy. So now let's deal with the suffix. Now we have 3 carbon atoms, which is PROP, prop, and it is an alkane because only single bonds are present throughout the structure. So we have AN plus the suffix, which is AL. So altogether we have 3 hydroxy propanol. That's the name of the second compound over here. I'm sure you're seeing every bit of what's going on and you're enjoying every bit of this. So now that we've named that, let's name the third compound. We have this compound over here, a cyclo compound. Now remember we said that when you have a compound that is in a ring structure, the first thing you do is to indicate that it is a ring structure by using the word cyclo. All right, so let's put this cyclo aside. We have some branches over here. We have one over here and we have another one over here. The first one is a halogen and the name is bromine. And when bromine is a side group or a branch, we use the name bromo, or we use the prefix rather, bromo. And we have methyl over here as the second substituent. Now in order of priority, okay, halogens are actually equal to alkyl substituents. So since they are equal, to know the one that we are going to assign priority to, we simply follow the alphabetical order. Now we have bromine. Bromine starts with the letter B and methyl starts with the letter M. B comes before N, so our priority is going to be on this bromine branch. So how are we going to assign priority to it? It means we're going to start counting from the carbon atom that contains or that carries this bromine branch. So we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. All right, so the parent name of this compound is cyclohexane because it is a cyclic compound having 6 carbon atoms, which has the name hex. It is an alkane because only single bonds are present in the compound, and then it is a cyclo compound, so that's why we have cyclohexane. So now let's deal with the prefixes by putting the names of the branches. On carbon number 1 we have bromine, so that tells us that we have 1 bromo. And then the next thing we identify is the position of the methyl substituent, which is 4 methyl. So altogether we have 1 bromo plus 4 methyl plus cyclohexane. So altogether the name of this compound becomes 1 bromo 4 methyl cyclohexane. That's the name of this compound. I'm sure you're seeing how everything is being played out right here. All right, so next on our list we have a few more questions to solve, and then we'll proceed from there. First on our list we have this. We have CH3 bonded to CH2 bonded to CH, which has an OH functional group bonded to CH3. So we can name, I think we have already dealt with this, but let's go ahead and name it anyways. We have 1, 2, 3, 4 carbon atoms. This is BUT. Plus we have an alcohol functional group over here, and it is on carbon number 2, so we have 2 all, and it is an alkane, so we have butan 2 all. Yes, we've dealt with this, but no problem. Repetition is the mother of mastery. So the next compound we have is this over here. We have CH3 bonded to CH2 bonded to COOH. So the number of carbon atoms we have are 3, 1, 2, 3. That gives us the name PROP, prop. And the functional group is COOH. So that means the suffix becomes propanoic acid. And it is an alkane. That's why we have AN in the name. The suffix is oic acid. The base name is prop. And since it's an alkane, it becomes plus AN and then plus the suffix, which is oic acid. So now we have already named this. Yes, that's the name. Propanoic acid. Some people can even be very zealous and say, go ahead to indicate the number of the functional group to be propan 1-oic acid. Whichever way you choose to do it is perfectly fine. Okay, so the next example that we have on the screen right now over here, we have CH3 bonded to CH, which has an hydroxyl or an alcohol functional group bonded to CH2 and then bonded to COOH. So now let's count the number of carbon atoms that we have. We have 1, 2, 3, 4 carbon atoms. 4 carbon atoms tells us that we have the parent name, but. So now this is the functional group that takes priority over this one. So the suffix will now be oic acid. And it's an alkane because only single bonds are present throughout the structure. So the parent name becomes butanoic acid. So let's identify the prefix. On carbon number 3, we have hydroxy because this alcohol functional group is treated as a branch now. So we have 3 hydroxy plus butanoic acid. Altogether we have 3 hydroxy butanoic acid. I'm sure you're enjoying every bit of all these questions that are being solved on screen today. All right, now I'll leave this last one for you to try out your hands on. I want you to name this compound and let me know what it is in the comment section below. I'll be waiting to receive the answer. So, here's a summary for quick revision for all we've been saying since the beginning of this series. To name an organic compound, you need to find the longest carbon chain, identify and number functional groups based on priority, use correct suffix and prefix rules, alphabetize substituents. You saw how we did the alphabetization of substituents when we had the methyl substituent and the bromine substituent. We gave priority to bromine because the two of them are equal in priority, but in terms of alphabetization, the letter B comes before the letter M. So the next thing to do is to apply position numbers correctly and then check for common mistakes like chain length, numbering, and prefix duplication. All right, so now here is a rundown of the top priority functional groups. We have the first one to be carboxylic acid, COOH, and the suffix is oic acid. Whenever you have it in a compound, the suffix of that compound becomes oic acid. The next one we have is the aldehyde functional group, CHO, and the suffix is al. The third one is the ketone functional group. The suffix is -one. And we have the hydroxy functional group or alcohol functional group. The suffix is ol. And then we have the amine functional group. The suffix is amine. When they are the main functional groups in compounds, that is the suffix that you use. But in cases where they are not the main functional groups, for example, let's say you have an alcohol functional group and it is not the main one, then you use the prefix hydroxy. When you have an aldehyde functional group that is not the main one, you use the prefix formyl. And then you have the ketone. If it is not the main functional group, you use the prefix oxo. And then when you have the amine functional group that is not the main one, you use the prefix amino. And then for halogens and alkyl functional groups are always used as prefixes. Whenever they appear in a compound and you want to name it, you start by using their name first. That's why you have names like 2-chloromethane. Their names will always come first. You can have 2-methyl butane. Their names will always come first if it is an alkyl or an halogen functional group. I want to thank you for staying till the end of this video. It's been a pleasure sticking around with you and making the concept of chemistry easier. If you're enjoying every bit of what we are doing here, I'd like you to do me a favor by liking, sharing, turning on the notification bell icon, and subscribing to my YouTube channel. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I will see you in the next video.